This is the last problem and last video series in the Chapter 7 set. So this is a similar figure problem, and the test, I'm not letting you use a calculator. So you need to be able to get through these problems without a calculator. And there's two techniques. One is finding and using an enlargement ratio, and the second one is using proportions. So we're going to go ahead and go over both of the techniques, and both of them without a calculator, which this tutorial especially assumes that you've been through both the fraction tutorials. So make sure you've gone through the fraction tutorials before doing this one. Otherwise, you'll be stuck on the fraction parts. All right, first of all, for enlargement ratios, what really matters is that this figure on the right-hand side is just a certain number times bigger than the left-hand side if these are really similar. So what you need to do is find out the enlargement ratio, and then once you, let's say this figure was twice as big, that would mean that you could multiply anything over here in the smaller figure by 2, and it would turn into the bigger number of figures. Like maybe 12 times 2 would have been 24 if this was really twice as big. And to go backwards, you would divide. Like if this was 24 right here, 24 divided by 2 would be 12. So once you know the enlargement ratio, it's just a matter of either multiplying to become bigger or dividing to get smaller. So let's find the enlargement ratio. To find the ratio, take two sides that are corresponding. Like here we have 12 is the top edge of the arrow, and 18 is the top edge of the larger arrow. So we can divide 18 by 12 to find out how many times bigger the large arrow is. So our enlargement ratio, put ER for enlargement ratio, equals a ratio of 18 over 12. If we had a calculator, we just would do decimals and it wouldn't be a problem. For us, there's no calculator, so let's reduce this. 18 and 12 can both be reduced by 6. So 18 divided by 6 is 3, and 12 divided by 6 is 2. So this is our enlargement ratio. It's 3/2 or 1.5 times bigger. So now to find x and y, we either multiply by 3/2 or we divide by 3/2 to make things smaller. So let's first focus on the x value. To find the x value, look at the corresponding part that x goes to. We have 4 and x are corresponding parts. They're both the left-hand edge of each figure. So to find x, we should take 4 and multiply it times 3/2 times bigger, and we'll be done. So to find x, we'll do take 4, multiply times 3/2, because that's how many times bigger the large arrow is. And from the first fraction tutorial, we know to put this over 1. We can either multiply across and then reduce, or reduce first. I'm going to multiply across. 4 times 3 is 12. 1 times 2 is 2. And then 2 goes into 12 exactly 6 times. So there's our x value. So x is 6. Now to find y, we have to do the opposite. We need to divide. So we got y equals, now look at the corresponding parts. Y is the lower right edge of the arrow. And same thing over here, 10 is the lower right edge of the bigger arrow. So to find the y value, we have to take 10 and divide by 3/2 to get the smaller amount, which is y. So let's take 10, and we want to divide this by our enlargement ratio, which is 3/2. And to do this without a fraction or without a calculator, we know from the fraction tutorials that to divide two fractions, you change it to a multiplication problem. So division by 3/2 is the same as multiplication by 2/3. And we'll finish this off. 10 times 2 is 20. And then 1 times 3 is 3. And we're done. 20/3 is the y value, which is 6 2/3. If you want to write it that way, that's fine. 6 2/3, not a problem. But 20/3 is sufficient for me. So there's our x and there's our y value without using a calculator. Next up, we're going to do the same problem but using proportions. So here's the proportion way. Using proportions, the key is when you set up your proportions, you need to do a consistent ratio. In our case, let's do a ratio of small to big. So we're going to take sides of the smaller and put them over corresponding sides of the bigger ratio. So let's start with two sides we actually know. We know 12 and 18, and those are both corresponding parts. So we'll start with 12 is the smaller, over 18 is the bigger. And let's set that equal to another set of corresponding parts. How about let's use the 4 and x. Now the direction matters. You can't just put 4 and x in random spots. Since we're doing a ratio of small to big, we have to put 4 over x because 4 is the smaller side and x is the larger side. Once you have your proportions set up, in our case small to big, now you can cross multiply. But even before doing that, I'm going to reduce 12 and 18 because those can both be divided by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. And now that'll make our fraction work a little bit easier. Let's go ahead and cross multiply. 3 times 4 is 12. And then you set that equal to the other direction. 2 times x is 2x. So there's a new equation. With cross multiplying, you multiply the crosses and set them equal to each other. So we've got 12 equals 2x, divide both sides by 2, and final solution is x equals 6, which is the same thing we had with the enlargement ratio method. So there's our x value. To find the y value, let's create some space down here to find y. Do the same thing. In fact, I'm just going to recopy this side over here and say we have our 2/3 back. So it would have been 12 over 18, but let's assume that I've already reduced it to 2/3. Then on the right-hand side, we need to set a ratio of small to big. So it'll be y over 10, because that's a ratio of small on top and to big on the bottom. And once again, let's cross multiply. So 3 times y is 3y. The other direction, 2 times 10 is 20. So this is a 2. And then divide both sides by 3. And we're done. Got the same answer as before. Y equals 20/3. So you choose whichever technique seems the easiest for you. They both work, and they're both full credit on the test. But that's it. Hope that helps. Have a great day.